Hello, my dear students. I hope you all are safe in this pandemic. Now, students, let us start today's lecture. Today, I will be taking class 9, chapter 2, exponents of real numbers. Now, let us start the lecture with full focus. Let us say me, what do you mean by exponents? The exponents, the term you have already studied in class 7, and you know what is exponents. Suppose I say 5 to the power 3. Let us start the exponents. Exponents of real number. Of real numbers. Of real numbers. If I say 5 to the power 3, here 5 is the base and 3 is the exponents. Suppose I say a to the power n, here a is the base and n is the exponents. Then the integral exponents of a real numbers. If I say a to the power n, what do you mean by a to the power n? At first, please say me, what do you mean by 5 to the power 3? 5 to the power 3 means 5 into 5 into 5. Multiply 5 3 times. This is the meaning of 5 to the power 3. If I say 8 square, what do you mean by 8 square? 8 square means multiply 8 2 times. Here 8 is called the base and 2 is called the exponents. In this way, when I say a to the power n, in this same way a to the power n means multiply a n times. This means a into a into a into a up to n times. This is the meaning of a to the power n. Here we discussed about the integers and exponents. Here a is any real number and n is the any integers. Here a is any real number. Suppose I say 3 upon 5 to the power 3. This means 3 upon 5 is a real number. 3 upon 5 into 3 means 3 times multiply 3 upon 5. Here this is 3 upon 5 is the base and 3 is the exponents here. Now let us discuss about the properties of exponents. Now let us discuss the properties of exponents. The first properties of exponents says that if I say here we discussed about the positive integers of exponents. 5 to the power 3 or 4 to the power 5. 4 to the power 5 means multiply 4 5 times. 4 into 4 into 4 into 4 into 4 into 4. This is the 4 to the power 5. If I say x to the power n, this is the multiply x into x into x n times. Here we discussed about the positive integers. Now let us discuss about the negative integers. The 5 to the power minus 3. Here 5 to the power minus 3, the exponents is a negative number. When the exponents is a negative number, this means that take the reciprocal of the base and make the exponents positive. 5 to the power minus 3 is equal to 1 upon 5 to the power 3. 1 upon 5 to the power 3 means 1 upon 5 into 1 upon 5 into 1 upon 5. Multiply 1 upon 5 3 times. In the same way, if I say a to the power minus n, here the n is the negative number, negative integers, exponents. This means 1 upon a to the power n. Here when the exponents is a negative number, make the reciprocal of the base and make the exponents a positive numbers. If I say a upon b to the power minus n, this is equal to b upon a to the power n. When the exponents is a negative number, then make the base take the reciprocal of the base and make the exponents positives. In the same way, please students say me, if I say, take an examples for better understandings. If I say 2 upon 5 to the power minus 4, here the exponents is a negative number, is a negative integers. Then how can we make the exponents as a positive numbers? We cannot solve a problems unless we make the exponents positives. We cannot get the value of 2 upon 5 to the power minus 4. Then at first we make the exponents positives. Unless we make the exponents positives, we cannot find the value of the given questions. Here the question is given, find the value of 2 upon 5 to the power minus 4. Then to make the exponents positives, take the reciprocal of the base. This is equal to 5 upon 2 to the power 4. Then here you make the exponents positives. Then very easily 5 upon 2 to the power 4 means, what do you mean by this? Multiply 5 upon 2 4 times. Then very easily you can find out the value of the given questions. Then students, when the exponents is a negative numbers, we cannot find its value, then change it into positives by making taking the reciprocal of the base and find the value. Look at here, this is an important point. Please students note down this. Please students note down these points and discuss another examples. Suppose a question is given 3 upon 4 to the power minus 3. Can you find out its value without making the exponents positive integers? Can anyone find its value? No. At first change the exponents as a positive integers. How can we change the exponents into positive integers? Only change the base. Only change the reciprocal of the base. 3 upon 4 to the power minus 3 means 4 upon 3 to the power 3. Then very easily you can find its value. 4 upon 3 to the power 3 means 4 multiply 4 upon 3 3 times. Then you can find out its value very easily. 4 4 is 16, 16 4 is 64 upon 27. Am I right? Am I right? Yes. Now let us discuss the other properties of the exponents. Now let us discuss the first property of the exponent says that a to the power m into a to the power n. The first property here, the property 1 says that a to the power m into a to the power n is equal to, when the base is same, the exponents get added. This is equal to a to the power m plus n. Take an examples. Suppose you say 2q into 2 to the power 5. Here the same base 2, here also 2. Then as for the property 1, we add the exponents. This is equal to 2 to the power 3 plus 5. Then suppose take another examples, 3 upon 5 to the power 3 into 3 upon 5 to the power 5. Then here also same base. Here the base is 3 upon 5 and 3 upon 5. Then easily take it, use the property 1. Get the exponents added. 3 plus 5, which is equal to, here 2 to the power 8. Here this is equal to 3 upon 5 to the power 8. Then now let us discuss the property 2. The property 2 says that when we divide, suppose a to the power m divide a to the power n. This is when the base is same and we divide, then the exponents get subtracted. Now let us take some examples for better understandings. If we say 5 to the power 3 divide 5 to the power 2. Here the base is same, then according to the property 2, the exponents get subtracted. This is equal to 5 to the power 3 minus 2, which is equal to 5 to the power 1 means 5. Take another examples. Suppose this is minus 2 upon 3 to the power 8 divide minus 2 upon 3 to the power 4. Then as here the base is same to minus 2 upon 3 and minus 2 upon 3 is the base of the questions. Then according to the property 2, then the exponents get subtracted. This is equal to minus 2 upon 3 8 minus 4, which is equal to minus 2 upon 3 to the power 4. Then multiply minus 2 upon 3 4 times. You can easily get the answers. Now let us discuss another property. Here the property 1, property 2. Now let us discuss what the property 3 says. Here the property 3 says that a to the power m whole n is equal to a to the power m into n. This means, suppose take an example here. Take an examples 2 to the power 3 whole 2. This is equal to 2 to the power 3 into 2. Let us explain it. Let us explain the property 3. The property 3 says that, now we will discuss in next page. Clear the canvas and progress. The property 3 says that a to the power m whole n is equal to a to the power m into n, which is equal to a to the power mn. Now let us explain it. A to the power m to the power n means multiply a to the power m n times. Multiply a to the power m n times. Okay. Then a to the power m means multiply a m times. Yes. Then this is multiply a m times. In every case multiply a m times. Okay. Then multiply a to the power m times, multiply a to the power m n times. A to the power m means a into a up to m times. Then this implies that we multiply m times n times. This means multiply a m into n times. Here m times, here m times, here m times. How many times m times? N times m times. This means this is equal to multiply a how many times? mn times. Okay. This is equal to a to the power mn. Then take an examples for better understandings. An example says that, suppose we say 2 upon 3 to the power 2 whole to the power 3. This is equal to 2 upon 3 to the power 2 into 3, which is equal to 2 upon 3 to the power 6. Okay. Then now explain the third law. Take another examples. Here another example says that, suppose 3 to the power 2 whole 5, which is equal to 3 to the power 2 into 5, which is equal to 3 to the power 10. Okay. Now let us discuss the fourth law. Here the first law says, let us recall the first law. What is the first law says? First law says a to the power m into a to the power n is equal to, when we multiply the same base, then the exponents get added. A to the power m plus n. When we divide and the base is same, a to the power m divide a to the power n. When we divide, in the case as the base is same, the exponents get subtracted. This is equal to a to the power m minus n. Then the third law says a to the power m whole to the power n is equal to a to the power m into n. Now let us discuss what is the fourth law says. Here the fourth law says Fourth law says here, suppose a upon b, ab to the power n is equal to a to the power n into b to the power n, and another thing says a upon b to the power n is equal to a to the power n upon b to the power n. Now let us explain this. The fourth law says ab to the power n. What do you mean by this? This means multiply ab n times, means ab into ab into ab. How many times? N times, because here the exponents is n. ab to the power n means multiply ab n times. ab into ab, how many times? N times. Am I right? This, if you split, ab means a into b. Here ab means a into b. Here ab means a into b. Okay? Then how many times? N times. Because here the exponents is n. Then split. Take the a, how many times? N times. Then another part, b into b, how many times? N times. Because the exponents is n, we multiply a, b n times. Then if we split a, b into b, in this way, if we take a, separate a and b among themselves, then take a one sides and take b another sides. Then here a into a n times and b into b is also n times. This is a into multiply a n times, means we can write this a to the power n. Then multiply b n times means b to the power n, which is equal to a b to the power a, which is equal to a n into b n. Okay. Now let us discuss this part, divide part. Here a upon b to the power n. We have to prove this. This is equal to a to the power n upon b to the power n. Then a upon b to the power n means a upon b into a upon b into a upon b. How many times? N times. Because the exponents is here n times. Then if we write the numerator as a into a, how many times? N times. Then in the denominator part is b. Here the denominator part is b. b into b into b, how many times? N times, which can be written as a to the power n upon b to the power n, which can be written as a to the power n upon b to the power n. Yes. Am I right? Yes. Now take some examples for better understanding. Then take some examples. Suppose I say 6 to the power 5. 6 can be split into 2 into 3 to the power 5. Yes. This is 2 into 3 to the power 5. This can be written as 2 to the power 5 into 3 to the power 5. Then take LHS and take RHS, then we can prove it. 6 to the power 5 means 6 into 6 into 6 into 6 into 6, 5 times. Here the RHS says 2 to the power, this is equal to, if we split 6 into 2 into 3, this is 2 into 3 to the power 5, then this is 2 to the power 5 into 3 to the power 5, then the RHS says 2 to the power 5 into 3 to the power 5, then 2 to the power 5 means 2 into 2 into 2 into 2, 5 times multiply 2, 3 to the power 5 means 3 into 3 into 3 into 3 into 3, 5 times 3. Then you can write this 2 into 3, 6 into 2 into 3, 6, 2 into 3, 6, then 2 into 3, 6, then 2 into 3, 6. Is this LHS? This is LHS? Yes. Then we can prove that 6 to the power 5, this means AB to the power n is equal to A to the power n into B to the power n. this is 6 to the power 5 is equal to 2 to the power 5 into 3 to the power 5. Okay. Then take another examples to prove that to prove this law, a upon b to the power n is equal to a to the power n upon b to the power n. Take 2 upon 5 to the power 4. 2 upon 5 to the power 4 means 2 upon 5 into 2 upon 5 into 2 upon 5 into 2 upon 5. Am I right? Am I right? 2 upon 5 to the power 4 means multiply 2 upon 5 4 times. Then 2 upon 5 into 2 upon 5 into 2 upon 5 into 2 upon 5. Then this is the numerator is 2 into 2 into 2 into 2. The denominator is 5 into 5 into 5 into 5. Then the numerator we get this is 2 to the power 4. The denominator we get 5 to the power 4. This means we can split this into this. Here this law is proof here. Here the LHS, here this is RHS. Here this is LHS, here this is RHS. Okay. Then take some more, discuss some more examples. Now discuss some more examples of exponents. Suppose you say you have to find the evaluate. Here the example says evaluate the value. Evaluate the value by applying the exponents laws. Here the question is given root 2 to the power 3, root 2 to the power 3 into root 2 to the power 5. Here recall the properties of exponents. Here the base is root 2 and the exponents base are same. Then when we multiply, you know the exponents get added. Root 2 to the power 3 into root 2 to the power 5 means root 2 to the power 3 plus 5, which is equal to root 2 to the power 8, which means this is 2 to the power 4. Because if you root 2 square 4, then this is root 2 square means 2 to the power 4, which is equal to 16. Then by applying the laws of exponents, we can easily find its value. Take another examples. Suppose root 3 to the power 3 into root 5 into root 3 to the power 7. Then divide root 3 to the power 4. Then here apply the laws of exponents. When we multiply, the exponents get added. This is equal to root 3 to the power 3 plus 7. Then divide root 3 to the power 4. Then here 3 plus 7 means root 3 to the power 10. Divide root 3 to the power 4. Then when we divide, please students recall, when we divide the exponents get subtracted. This is equal to root 3 to the power 10 minus 4, which is equal to root 3 to the power 6. Then root 3 to the power 6 means root 3 square to the power 3, which is equal to 3 to the power, which is equal to 3 to the power q. This is equal to 27. Then by using the laws of exponents, very easily we can find out, we can solve these problems and evaluate the value of these questions. Okay. Then take some more examples. And discuss the laws of exponents. Then what is the next law says? Then the next law of exponents says that, fifth law says that x to the power 0 is equal to 1. What may be the base? This is not matter. What may be the base to the power when the exponents is 0, we get the value 1. Suppose I say 1000 to the power 0. This is also equal to n. 1 to the power 0. This is also equal to n. What may be the base? This doesn't matter. When the exponents is 0, the value is 1. Suppose I say 5 upon 17 to the power 0. Then this is also equal to 1. Because I have already told you what may be the base, this doesn't matter. When the exponents is 0, then the value is 1. Okay. Then what the other laws says. Then let us discuss the all laws of the exponents. First law, law 1 says, let us recall this. A to the power m into a to the power n is equal to a to the power m plus n. Then the second law says, a to the power m divide a to the power n is equal to a to the power m minus n. Then the third law says, a to the power m whole n is equal to a to the power fn. Okay. Then the fourth law says, a to the power minus n is equal to a to the power n. Then the fifth law says, suppose here a to the power m a upon b to the power n is equal to a to the power n upon b to the power n, or and a b to the power n is equal to a to the power n into b to the power n. Then the another law, sixth law says that, a to the power m upon n is equal to a to the power m whole 1 upon n. Okay. Then split m upon n into m into 1 upon n. Then the seventh law says this, a upon b to the power n is equal to a to the power n upon b to the power n. Now let us discuss some questions about the theory. Okay. Then now let us practice variety of questions. Here the question says that evaluate the value of 27 to the power 2 by 3. Here evaluate the value 27 to the power 2 by 3. Now 27 to the power 2 by 3, then 27 2 by 3 can be written as 1 upon 3 into 2. Okay. Then here we can write 27 to the power 1 upon 3 whole to the power 2. Yes. Then 27 to the power 1 upon 3 means 27 cube root of 27 square. Then cube root of 27 is 3. 3 square is equal to 9. Very easily we can find out its value. Then now let us discuss some more examples. Then in another way you can solve also this 27 to the power 2 by 3. It can also split as 27 square to the power 1 upon 3. 27 square is 729. 729 1 upon to the power 1 upon 3 means cubic root of 729. Cubic root of 729 is 9. Here you may solve in any way. This is a first way, this is the second way. In any way you solve, you can get the same answer. Answers. Now let us discuss some more problems. Here another question says that, here, please students do your exercises regularly. Knowing theory is not sufficient for a math students. You do your exercises and ask me your doubt. I am ever ready to clear your all doubts. Here evaluate the value. Look at here. When you look at the questions, you think it may be a complicated, but it is not a complicated question. This is very easy. When you apply the laws of exponents, you can easily solve this. 1 upon this 4 to the power minus 5 cube root. Then simplify this. 4 to the power minus 5 into cube root can be written as 1 upon 3. Then this is 1 upon 4 to the power minus 5 upon 3. I have already told you a to the power minus n means a to the power n. Then when you get negative exponents, take the reciprocal of the base. Then here you can write this as 4 to the power 5 upon 3. Then here 1 upon 4 to the power minus 5 upon 3 means here this is 1 upon 4 to the power minus 5 upon 3 means this can be written as 4 to the power 5 upon 3. Then 4 to the power 5 upon 3 means 4 to the power 5 into 1 upon 3 into 1 upon 3. Then 4 to the power 5 means multiply 4 into 4 into 4. How many times? 5 times. Then multiply it 5 times. Then find its cube root. Then when you multiply 4 5 times, this means the and find out its cube root. You can easily solve this and find out its cube root. Okay. Then here take another questions. Here take another questions. Then you can solve this another questions. Let us solve some more questions. Here another question says that. Here another question says that. Let us find the value 25 to the power minus 1 upon 3. 25 to the power minus 1 upon 3 into 16 cube root. Into 16 cube root. Then look at here. 25 to the power minus 1 upon 3. Here 25 to the power minus 1 upon 3 into 16 to the power 1 upon 3. This can be written as, here the exponent is negative. Then take its reciprocal and make the exponents positives. This is 1 upon 25 to the power 1 upon 3 into 16 to the power 1 upon 3. Here the exponents are same. Then you can write this as 16 upon 20 to the power 1 upon 3. Then this can be written as 16 upon 25 to the power 1 upon 3. Then you can write it as 25 can be written as, this is 4 square, this is 4 square or 2 to the power 4 upon 5 square to the power 1 upon 3. Then you can simplify this and you can get this as 2 to the power 3 upon 5 to the power, if you multiply 5 here and multiply 5 square into 5 means 5 to the power 3, multiply 5 here, and this is another 2. If you split 2 to the power 4 into 2 to the power 3 into 2, then this to the power 1 upon 3. This is equal to 2 upon 5 to the power 1 upon 3 means this is 2 upon 5 into 10 to the power 1 upon 3. This is the simplification of this given questions. Okay. Then now let us solve some more examples. Here another question says that, please students do your exercises. Here also evaluate the value of 256 upon 81 to the power 256 upon 81 to the power 5 upon 3, 5 upon 4. Then this means 256 upon 81 to the power 1 upon 4 whole to the power 5. Then I can split the 5 upon 4 in 1 upon 4 into 5. 5 upon 4 can be split it into, I can write this into 5 into 1 upon 4. Then I use the laws of exponents and split it into in this way. Then 256 to the power 1 upon 4 means fourth root of 256, and 81 to the power 1 upon 4 means fourth root of 81. The fourth root of 256 is 4 and fourth root of 81 is 3. This is 4 upon 3. 4 256 can be written as 4 to the power 4 and 81 can be written as 3 to the power 4. Then this upon 1 upon 4 whole to the power 5. This is equal to 4 upon 3 whole to the power 5. Then you can find its value 4 upon 5 upon 3 upon 3 4 4 exponents 5 and 3 to the power 5. 4 to the power 5 upon 3 to the power 5. Then you can find 4 to the power 5 is 1024 and 3 to the power 5 is 243. Then by solving this you can get this. Evaluate the value. When you see the questions you think this will be a complicated answers, but you just apply the laws of exponents and easily you solve this. Now let us practice some more examples. Here another example says, students please do your exercises. Another example says that 81 upon 16 to the power minus 3 by 4. When you see the questions, you think it will be complicated. But no, apply the laws of exponents. You know when a to the power minus n is equal to 1 upon a to the power n. Means when the exponents is negative, just take the reciprocal of the base. This is equal to 16 upon 81 to the power 3 by 4. Then split it into 16 upon 81 to the power 1 upon 4 whole to the power q. I just split 3 upon 4 into two parts. 3 upon 4 can be written as 3 into 1 by 4. Am I right? Then I split it into two parts. Recall the exponents. X to the power m n can be written as x to the power m n. In the same way I split it. Then 16 can be written as 2 to the power 4. 81 can be written as 3 to the power 4 whole to the power 1 by 4 into whole to the power 3, which is equal to 2 by 3 whole to the power 3, which is equal to 8 by 27. When you see these questions, you think minus 3 by 4 exponents, how can we solve it? But apply the laws of exponents and very easily you can simplify these questions and you get the answers. Okay. Thank you students. Today this much. And in my next sessions we will continue this. Till then, happy learning.